Hello students, I am Rohitash Singh Chouhan and I am here for discussing about diffusion and oxidation. In this topic, we have discussed so far about fixed first law of diffusion and the fixed second law of diffusion. Now we are having analytic solution of fixed law, constant surface concentration. The equation is given as del n xt by del t is equals to d del square n xt by del x square. Equation shows fixed second law. Let's suppose for constant surface concentration, initial conditions are t is equals to at t is equals to 0 and x0 is equals to 0. Boundary conditions are n0 t is equals to ns and n infinity t is equals to 0. The solution of the equation is nxt is equals to ns error function x2 dt, where ns is equals to constant surface concentration, x is the distance up to which diffusion take place, and t is the total diffusion time. So this is analytic solution of Fick's law at constant surface concentration. Now we are having constant total dopant. Then we are having, let us suppose that the layer of dopant is deposited on silicon surface with fixed total amount of dopant is deposited on silicon surface with fixed amount of dopant theta t per unit area. Initial conditions are given as nx0 is equals to 0 and the bounding conditions are integration 0 to infinite nxt is equals to theta t and n4 comma t is equals to 0. So the solution of Fick's law becomes nxt theta d upon under root pi dt exponential x square 4 dt. When x is equals to 0, nxt is equals to ns is equals to theta t by pi dt. This solution is called Gaussian distribution. So this is about constant total dopant. Now we are having correction to the simple theory. In the discussion of Fick's law, we assumed that the electric field is not present while measuring the flux density. If an electric field is also present, then we have to correct the simple theory approach as substitutional impurities are almost completely ionized at and above room temperature. So for that reason, we are doing correction to the simple theory. Now total current is equals to diffusion current and plus diff current, and the flux density is phi is equals to minus d del n upon del x plus mu n ex, where mu mobility and ex is the applied electric field. In semiconductor, the field is given as ex is equals to minus eta kt upon q 1 upon n upon del x. So the flux density phi is equals to minus d del n upon del x plus mu n in the brackets minus eta kt upon q 1 upon n upon del x. The equation can be simplified to the form that it would be equal to minus d1 plus eta del n upon del x. Now eta is the screening factor which lies from 0 to 1. When eta is 0, then phi is equals to minus d del n upon del x. This is the equation of Fick's first law. So this is all about correction to the simple theory. Now this topic is over. Thank you.